All right, so 2.6 exploration. What we're going to do here is there's a whole list of functions over here, and we're going to try to use our graphing calculator to put this function in and then try to match it up with which one it is on here. So this is where that Calculate 84 app is going to come in handy. So if you've not yet downloaded that, you're going to want to. If you have an iPhone, it's going to look like this, Calculate 84. Right there in that top left, this one right here. If you have an Android, you'll want to use the Wabbit app. When you go to Calculate 84, you don't have to sign in at all. I always hit skip for now. Looks like this, and then what we'll be able to do is we're going to graph these. So we are going to start with the very first one. So we're going to go to y equals. In order to get the absolute value bars in there, we have to hit the math button, the right arrow, and then number 1 will say absolute value. I'll do that again. So we're back at y equals. We're going to hit the math button, which is right under alpha. You'll hit the right arrow, and then number 1 says absolute value. If you hit enter, it puts in the absolute value bars. On the inside, we have x plus 5. The x is right next to alpha, so you're going to put that in. When you hit graph, you can see that the vertex of this graph is to the left of the origin. So let's find which one matches on here with that. So, and we can click on it and we can see that that vertex is at, again, if you click on it, you're going to have to be pretty picky. If you hit trace, you could hit -5 and then it will tell you -5, 0 is where that point is. So you can see that's where that vertex is at -5, 0. So these vertexes, here, that one's at 4, 0, that's at 0, 0, that's at -5, 0. So that one looks to be the right one, but let's double check. This one doesn't have any with the vertex to the left, neither does this one. So this is what it narrows it down to be. So we're going to write that in right there. Let's move down to the next one. We're going to go back to y equals. We can clear that equation out. This time, math, right arrow, absolute value. We have the absolute value of x on the inside and plus 5 on the outside. When you hit graph, you'll see this time that our vertex, let's see if I can locate it, is right about there. So it's about 0, 5. Now this one does not have any vertices at 0, 5. This one does, right here, and this one, all the vertices are at the origin. So this one here is that one. So f of x equals the absolute value of x plus 5. So what you're going to do is I want you to play around with this, and I want you to plug these all in and see if you can identify where each of them go. So that's what you're going to do right now. Okay, so what I did was I went through and I filled in all of the ones that I found. Okay, now you'll notice that that f of x equals the absolute value of x, that shows up in many of these. That's the one that has the origin, is the vertex is at the origin, and it's going up one, out one, up one, out one. So it's on this perfect diagonal. Perfect diagonal, origin is where the vertex is. It's perfect diagonal here. Now the one that's narrower down here, we found that one to be the one with the 2 out front. The one that's wider is the one with the 1/2 out front. The one with the negative, we actually already talked about that if it's a negative, that's the only chance that the V will be upside down and be like that mountaintop. So let's see if we can kind of come up with what to write over here. So let's look at what is going on. In order for this to shift left and right, you're either adding or subtracting on the inside of the absolute value bars. So we're going to write this as a sentence here. So if you add a number on the inside of the, and I'm just going to write them, absolute value bars, the vertex will shift. So when we added a number, it shifted left. If you subtract, that's when the vertex shifted right. Now, in the next one, in this middle one, you're either adding a number or subtracting a number, but these ones are on the outside. How does that affect it differently? These ones, the vertex is shifting either up or down. So if you add a number on the outside of the absolute value bars, the vertex will shift. So when we add it, it went up. If you subtract, the vertex will shift down. So when we subtracted, it shifted down. Notice if you're not adding a number, where was that vertex? At 0, 0 both times. Okay? So we start at 0, 0, and then depending on if you're adding or subtracting a number on the inside or outside, it will shift left, down, up, or right. Now, there are no shifts in this last one because all the vertices are at the origin, at that 0, 0 point. But if you multiply by a number out front, it will change how steep the V is. Okay? If it is negative, it will flip. And we'll put in parentheses the upside down looking V. So we know what it flips to look like. Okay. Now these numbers on the outside actually have a little bit more meaning. If you actually paid attention to this, that is actually going to be your slope. So you actually go up 1, out 2. So this slope is positive 1/2. So up 1, right 2, up 1, right 2, up 1, right 2. This one go up 1, left 2, up 1, left 2. It's a negative 1/2. Okay. So when they're looking at 1/2, it's going up 1, out 2, up 1, out 2. But when this one had a slope of 2, what was actually happening is you would go up 2, out 1, because your slope is like 2 or negative 2. So up 2, out 1, up 2, out 1, up 2, out 1 to figure out those slopes. So that number out front will actually help you when it comes to graphing. Okay, this was the exploration. It kind of helps us. These are more like the examples that we're going to do, but then we're going to use those to actually write our rules, which is on the back. You flip it over. The rules, that's what we're going to do today. So our 2.6 is to analyze translations, stretches, shrinks, and reflections. The parent function, now there's a parent function to all the different functions that we do. A parent function is the simplest form of a function with a specific characteristic. Now what that means is if it was quadratic, then it has to have the x squared to be a quadratic. So you don't have a number out front, you're not adding a plus x or plus 3 at the end, you don't have other terms, you don't have a multiplier out front. If it's a square root, it would have to have a square root sign, but you're not adding or subtracting anything on the end, you don't have a multiplier out front. If it was the absolute value, you're not adding or subtracting anything, you don't have a multiplier out front. So if it's a linear, like the form of y equals mx plus b, you get rid of the number out front, you don't have the multiplier, and you don't have a y-intercept that you show because it's going to be plus 0. But you take away all the extras and you keep just the simplest form of any of these functions. These are what we call the parent functions. So we have a lot of different functions that we're going to learn throughout this year, and each time we talk about a parent function, the parent function always is going to be the simplest form of a function. A translation can just shift a graph. You guys learned about translations in geometry. It can shift horizontally vertically, or both. It could be a combination of horizontally and vertically. Okay. So we talked about this on the page before with the exploration. If you have the function, so here's our function, is the absolute value of x. If you add a number on the outside, that's when it goes up k units. Okay. If you were to subtract it, that's when it goes down k units. Or if you take any parent function and subtract k from it, on the outside of that, then it will be down k units. It goes left and right if it's on the inside of our function. So it went right, if you look back here, the one that went right, we actually were subtracting. So if you have y equals the absolute value of x minus k, and that's on the inside, then what will happen is it will go to the right k units. If it's in any parent function, okay, so it'd have to be on the inside of the function, not on the outside. This is just general rules, but we're applying it to the absolute value with this section. Okay. If you wanted it to go left, you would have to add that value on the inside of that function. So for instance, if we look back here, now if we look at these, we know, looking at this, it would go left 5. This would go up 5. We didn't talk about that. We haven't talked about that yet. This one would go to the right 4. This one would go down 4. So you can see the difference with adding on the inside or the outside, or subtracting on the inside or the outside, and how those move. Okay. So a vertical stretch is when you multiply, this multiplies y by a factor of a such that a is bigger than 1. Now a is not going to include 1 because when you multiply by 1 it doesn't change, but if you multiply by a number larger than 1 then it's going to stretch. If you multiply by a factor of a, and a is between 0 and 1, it's going to be a shrink. If you multiply by 1/2 or 3/4 or 2/3, those numbers are going to get smaller. If you do a reflection, it's going to flip. This flips over the x-axis, which is when you get that upside down V, or that mountaintop. Flips over the x-axis. This is when the multiplier is negative. That's when that happens. So if a was a negative value, or if you put a negative sign in front of whatever that a value is. Okay. So we're going to do a couple of examples. So a vertical stretch, an example of a stretch would be if you had like y equals 4 times the absolute value of x. 4 would make it a stretch. Whereas if you had y equals 1/2 times the absolute value of x, that would be a shrink, because 1/2, when you multiply by 1/2, things get smaller. Okay. Now, if I use the fraction y equals 4/3 times the absolute value of x, which one would that fit into? That number, 4/3, since the numerator is larger than the denominator, would be bigger than 1. So that actually, this would be an example of a stretch. It would fit in up here, because 4/3 is bigger than 1. The fraction would have to be between 0 and 1 for it to be a shrink, and 4/3 is not between 0 and 1. Okay. A reflection is just anything with a negative. So if you have negative of the parent function. So in this case, if you had y equals negative the absolute value of x, we know that that's when you're going to have that upside down V. You could also combine a stretch or shrink along with a flip. So a combination would be something like y equals -3 times the absolute value of x. That's going to be a stretch, but it's also going to be a flip. Okay. So let me go over the assignment a little bit with you, because this assignment is, we didn't do many example problems. Like I said, The exploration was doing those example problems together, which you didn't have to graph. Our parent function is always going to be the same. So when we're talking about an absolute value function, the parent function is y equals the absolute value of x. So you want to start by graphing this. Again, you can always come up with a table. Okay. Now the origin, when there's no shifts, is going, or the vertex, sorry, is going to be at the origin, 0, 0. So plug in a couple values. And let's find it. The absolute value of -2 is 2. The absolute value of -1 is 1. The absolute value of 1 is 1. The absolute value of 2 is 2. So when we go to graph our parent function, make sure you have scales on your graph always. So we have 1, 1, 2, 2 in the opposite direction. So even though I only have those 4 points on there, I can continue the pattern and find all the points in that direction and all the points in this direction. Now that's going to be your parent function. So that's your basic function. Now we can apply these shortcuts. So if I know this goes down 3, okay, it says state the parent function, then graph the parent function. State the shift of each function, and then graph the function. This is going to go down 3. So what I'm going to do is I'm going to move each of these points down 3, down 3, down 3. This one goes down 3, down 3. And from there I can see where that pattern is going. I can put all these extra points in there. I can see where this pattern is going. I can put all those points in there. And now I connect those points. And voila, I know how to graph that function without having to make a table or using a graphing calculator or writing 2 linear equations. I can graph it just by knowing that that's going to take the parent function and shift it down 3. So now you guys can do B, C, and D. Write an equation for each vertical translation. Vertical means up or down. Okay, so if it's going down 2/3 of a unit, you have to remember if it's vertical or horizontal, which one is adding or subtracting, and which one is on the inside versus the outside. So you should have an equation, something like y equals, it's going to have an absolute value of x in it. Now you're going to have to either add or subtract a number on the inside or add or subtract a number on the outside. So you have to figure out what goes there. Okay, so is it on the inside, absolute value, or is it going to be on the outside, the absolute value? So you'll have to finish that one. For each function, identify the translation of the parent function. So all of these are adding or subtracting on the inside. So does that mean it moves left or right or up or down? So that's what you need to say. This goes up 4, down 4, left 4, right 4. So that's what you should write right here. Okay, same with these ones. These ones all have the same type of v as our parent function. They're just going up 1, out 1. So how did this one shift? This one, from the origin, it went left 2. So how would we write that equation? This one went to the right 3. So how would we write that equation? This one went to the right 4. So how would we write that equation? Flipping it over, describe the transformation, and then graph each function. So how does this one move? Left, right, up, or down? Okay, so that'll help you tell you where the vertex is. And then the 1/2 should tell you how it's going to move from that vertex. So because it's 1/2, it tells you that the slope is going to be 1/2 or -1/2. So is it going to go up 1, out 2, up 1, out 2? Or is it going to be an upside down V and go down 1, out 2, down 1, out 2? This one, you're going to want to state how it's shifting, left or right, up or down. And then the 2 will help you find more points once you plot the vertex. Okay. For 15, 16, and 17, you just have to describe the translation as vertical, horizontal, or combined. So if it's combined, it means it shifts vertically and horizontally. And then describe the translation. So how is it moving up, down, left, right, and how many? Okay, so that should help you with that assignment.